Great, great, good deal. You bet. Okay, hold on one sec. All right. Well, thank you all very much and good morning. My name is Frank Orr. I work for Woolpert, and I'm going to be talking about a perfect storm water management system. Sorry for the bad pun, but this is using GIS for Toledo, City of Toledo stormwater program updates. So just a little bit about Woolpert, first and foremost. Those of you in the state of Ohio probably have heard of Woolpert at one point or another. We've been around since 1911. We were founded in Dayton, Ohio. In fact, among our first customers was the Wright Brothers Corporation. So we've been doing business in the state of Ohio for a long time. We've grown to roughly 40 offices worldwide. This information is probably a little bit dated now, so we might have a few more. And we've grown probably closer to 1,800 global employees now. We've been in a period of acquisition. We've been adding some companies. So the company has roughly doubled in size since I've been there, which is for about the last 4.5 years. Our areas of specialization, we call ourselves the world's largest AEG company, and it's easy to call yourself the largest when you make up the name. But you've heard of AEC companies. We call ourselves an AEG. That's architecture, engineering, and geospatial. And that is where I reside, is in the geospatial sector within Woolpert. My background is as a GIS analyst. I started with CH2 on Hill, a company which unfortunately no longer exists, a long time ago, longer ago than I care to admit, as a GIS analyst. And I am a geospatial project manager for Woolpert. I get to work on a lot of interesting projects in our geospatial sector, ranging from everything from data acquisition, LiDAR, all the way through systems integration, custom application development. So Woolpert does provide the kind of full spectrum of geospatial services, soup to nuts, as I like to say, everything from research and development. So things like sensor development. So actually, developing custom sensors for the acquisition of aerial LiDAR and imagery. And then, of course, we do a lot of that acquisition ourselves. We actually own planes, we own boats. So we do not only LiDAR, but also bathymetry. And we also have a very robust survey group as well. So pretty much any kind of data that you need acquired, we have the folks and the technology to do it. I work more on the right-hand side of this capabilities bar, if you will, really looking at some of the derivative products that we create after we go out and acquire the data. And then really on that far right side, talking about insight. One of the things we do is kind of help our customers not only acquire the data, but now you have the data, what are you going to do with it? So to turn that data into what I like to call actionable information, right? What are the insights that you can glean from that data? So that includes, data visualization, systems integration, and application development. And the project that I'm going to describe today involves pretty much the full range of our capabilities here. So as I mentioned before, Toledo, City of Toledo, Ohio is our customer for this project. The 2020 population of Toledo is just over 275,000. Of course, it's the fourth biggest city in the state. It's got over 2,000 city employees. And germane to what we're talking about today, it's got almost 97,000. That's kind of an exact number, and that number is probably growing or shrinking as we speak. But over almost 97,000 stormwater customers. So those stormwater customers are also water customers for the most part with the city. You can be a stormwater customer and not be a water customer. We'll talk a little bit about stormwater and what that is. I think most people are familiar with it, but I will talk about that a little more in a second. One of the stated goals of the City of Toledo is to leverage technology and data throughout the organization for more efficient service delivery. And we see this with a lot of folks, a lot of counties, a lot of cities really are striving to become data-driven organizations. So again, we have a lot of data, we being the cities and counties collectively. How can we use that data to make better decisions? And how do we get that information into the hands of the folks who need to make those decisions? So a little bit of background on the stormwater program. The City of Toledo manages a citywide stormwater program, including most of their stormwater customers are within Toledo city limits. They have a lot of water customers that are outside city limits as well, but most of their stormwater customers are managed within the city. The city charges customers a stormwater fee along with their water bill. It's a pretty nominal fee. It is charged every month with their water bill. The fee is based on the idea of what's called an equivalent residential unit, or ERU. You may or may not have heard of this term, but an ERU is a way of sort of generalizing what the fee will be for residential parcels month to month. So one ERU is roughly equal to about 2,500 square feet of impervious surface. Interestingly, I'll get into our analysis and the data that we developed for the city here. But what we found is that when we got new impervious surface data for the city and we averaged it across all the residential parcels, it came out to about 2,598 square feet. So it's pretty close. So whoever determined what that 2,500 square feet was going to be the average that a residential parcel was going to be charged back in close to 20 years ago did a pretty good job. So impervious surface is anything that water will not soak into, essentially. So rainwater falls, things like concrete, asphalt, buildings, etc., and has now been extended to things like gravel and hard packed surfaces, hard packed dirt surfaces as well. We'll talk about that in a little bit. So that needs to be managed, obviously, with the increase in the amount of impervious surface in cities as cities expand and develop, and land use changes can be very impactful, especially in this era of extreme weather events where we're getting a lot of rain, sometimes in a very short period of time. It can be crucial to understand how much impervious surface you have. So the city's been using GIS to manage this process since about 2004. And they've also been using a billing system, for billing their water and stormwater customers that was made by SAP since about the same time. And one of the issues that I'll get into here when I talk about the problems are that right now the city is maintaining their stormwater data by hand, if you will. They're not employing a lot of automation. They are being somewhat reactive in terms of how they update their impervious surface information. As you can see here in this screen on the right, this is an example of the current impervious surface layer. As you can see, I'm going to go ahead and use my pointer here. We have impervious surface layers for what appear to be, commercial buildings. So these are commercial properties. Commercial properties are actually charged differently than residential properties. They are charged by the ERU, but really it's the total amount of impervious surface divided by 2,500 to give an ERU value. So a commercial property might be charged anywhere from 2, 3, 5, up to hundreds of ERUs per month, depending on the amount of impervious surface. For example, there's a large property here. So you can see, just in this example, that we've got some areas that are maybe outside of the ERU layer, of the impervious surface layer that aren't being captured. So skipping down to the bottom here, the city's leaving money on the table in terms of what they can be charging folks. And it is a sort of an onerous process for the GIS staff month to month to try to keep up with this. The current driver is really either customer complaints or new customers. So when they add a customer to the system, they will go out. If it's a commercial customer, they'll go out and they will digitize that impervious surface area. But again, it's done sort of on an ad hoc basis and not systematic. And they don't have the sort of data to support those. It's really being done very reactively. That said, they've done, I think, an excellent job keeping up over the years. But unfortunately, it requires a lot of staff time to do so. So the solution, Woolpert has been engaged with the city for a long time. Really, one of the first drivers of this whole process was the fact that using some new and emerging technology and also some more recently acquired data sets, the city was able to develop a new impervious surface layer. And so that specific layer that you see here on the right has been the driver for a lot of these changes that are taking place. One thing to note here on this layer is we are collecting not only traditional impervious surfaces like rooftops, concrete, walkways, etc., but also, and you can see here, actually gathering some gravel and hard packed dirt surfaces as well. So that's something new for the city. So the solution is really to, number one, have a process by which you have a consistent sort of data-driven impervious surface generation. So something that can happen on a cyclical basis, maybe every 3 years as you're acquiring new data, new LiDAR, and new aerial imagery. There was need for a one-time data sync between GIS and SAP. SAP, of course, is the building system. As we discussed before, there's been a lot of data divergence between these two systems. So we needed to kind of bring those systems up to speed and get them synced up. And then once we get them synced up, how are we going to maintain that linkage over time? Number one, determining what that linkage is going to look like, and then developing tools to maintain that over time so that it just doesn't happen again after we do this one-time sync up. Using this new data, we can support changes to the billing rate, to the billing process. That was part of this project as well, is trying to understand what that is. It was actually a rate analysis to look at how much they were charging per ERU. Providing internal systems for program management, customer support, and then finally providing external facing maps and applications to educate and perform outreach for the community over some of the changes that may be coming their way related to their stormwater bill. So as I mentioned, really the data-driven impervious surface generation is really one of the first things. And again, this was sort of the driver of the whole project. But the concept here is that, we are collecting data on a cyclical basis every 3 years for the city. A lot of this is done, through the OSIP program. So we're collecting LiDAR. LiDAR generates digital elevation models, 4-band imagery. We're also collecting, so that gives us, red, green, blue, and also hyperspectral. So we can use this information, combine this information together in a way that allows us to, I'm not going to say automatically, but I will say more efficiently create an impervious surface layer. So again, very, very high level diagram of the process. Again, we've got the inputs on the right of that new aerial data. There is an automated feature extraction process. So some of those features, some of that impervious information can be extracted relatively easily in an automated way. Building outlines is a good example because you have very sharp surfaces and sharp edges to buildings. They can be very easy to see. They're not often covered up by trees and other blockages. So we have part of that process is to the things that we can see in the imagery, the things that we can see in the LiDAR, we can combine that data to extract a lot of those features in an automated way. So is it machine learning? Sure. I would call it almost a machine assisted process because, of course, there's always a manual digitization part of that. So we're going to take that data out of that automated process, and then there's going to have to get human eyes on it and human hands doing some of that work to complete that data set. Part of the process too is field verification. So actually verifying that data in the field. And then you tweak that model. So it's kind of a feedback loop, and that's where the machine learning component comes in, is we're gonna tweak that model so we can do better automated feature extraction. And then we kind of work back through the process again until we have a finished product with which we are satisfied. So what that product looks like, again, we've got hard surfaces, so impervious surface, also hard packed gravel, hard packed dirt and gravel surfaces. And really the final step at this point is to overlay parcel data from the county to generate an impervious surface per parcel, because that is going to drive that data connection. It's going to drive, obviously, what we are charging those folks going forward. So once we have this data, once we have things outlined by parcel, we talked about that data connection, right? So now we've got impervious surface per parcel. That's in our enterprise GIS. Now we need to link that up to our billing information in SAP. So a really high level entity relationship diagram looking at SAP in blue on the left and GIS on the right. We've got account information, we have premise information, and the premise is basically the service location, right? So it's where water service is being provided. It's where stormwater, it helps identify the customer of the property. The account can change because people can move, there can be new accounts, but the premise remains associated with that property unless there's a major change to that property, like the property is leveled or demoed or completely revamped. So really, the important part of what we're talking about here is this connective tissue in the middle. And I guess in a nutshell, when you come right down to it, that is the sort of primary reason for doing this project, is to create this connection and maintain it over time. So let me go ahead and get into some of the process of how we did this one-time data synchronization. So what you see on the screen is a lot of points with a lot of different addresses and some other information. We'll dive into detail on this in a second. But again, at the end of the day, it's really the premise number that's coming out of the billing system. It's the parcel ID that's coming out of the GIS, and it's the linkage between those two things that we are trying to achieve here. So diving into a little detail, if you can see this, hopefully you can see this okay. I kind of zoomed in a little bit. But this one-time synchronization was the biggest individual component of this project. Step one was to take some of the tabular information from SAP. So they have address information associated with their accounts and geocode that. So put that on a map. Excuse me. And then step two was to find points outside of parcels, right? So get the latest and greatest county parcels. Again, if you can see this visually, when we talk about connecting this data together, it's really physically, in some cases, moving those points to within those parcels so we can do that spatial join, so we can connect those things. So when we geocode those, sometimes they end up directly inside. Sometimes we need to kind of work through, kind of point by point. Step three was to validate and match some of this address information using regular expressions with owner and address. So basically finding commonality between different data sets where maybe they had the same address number. We can sort of compare those together. So we try to automate this process as much as possible, but of course, at the end of the day, brute force is step four. And I'm minimizing this process a little bit, but at the end of the day, we had to get eyes on map elements and really just physically move points around. So if you can see kind of well enough, here's an example of a parcel, right? So we've got a parcel from Luca County. We have this sort of pink square here is a geocoded SAP account address, right? So you can see here that says 2652. We've also got a water meter location. So the city did have water meter information. The water meters have addresses associated with it as well. So you can see that here. That's also 2652. So that's good. Everything's driving up. We have a parcel centroid address. So we just created centroids in the parcels, and that says 2652 as well. So now we've got everything sort of joined up, and this one's all hunky-dory. We also have this orange area, which are QA, QC polygons. So as our team of folks were going through, they would actually create polygons around areas that were somewhat problematic. So just to highlight some of the issues we ran into, this is a very kind of a simplified example, but you can see here we've got an SAP account address that geocoded to 2660. It's out here in the right of way. So we put a box around it just to flag it for later review. Well, as you can see, this is 2660. If we move up the street a little bit, we've got a 2658 where these are jiving. So we have a meter and we have a parcel address, and then we have a 2662. There's no 2660. But looking at the latest aerial imagery, we can see that this is indeed one property. There's one house that occupies these two lots. So we're going to, at that point, compare potentially the owner, or we're just going to make a guess and we're going to say, you know what, this should actually be associated with this parcel. And here's the key. We need to duplicate this 2660 point and put one here and one here. The idea is to maintain that many-to-many relationship that exists for these features. So one premise may be comprised of two parcels, and we need to maintain that over time. Oh yeah, sorry, got ahead of myself. So I don't expect this just to show you kind of what that connective tissue looks like. Again, at the end of the day, this is the SAP GIS Connect table. This is what's going to connect these disparate data sets together, and this is what's going to be maintained over time. So just to zoom in a little bit, this is where the magic happens, if you will. We've got the SAP premise number, we've got the GIS parcel ID, and this is showing that connection. So this isn't exactly the area I was looking at before, but as you can see here, we have a premise number here. We've got three rows with that premise number because it's these three parcels that are associated with that premise number. So a little bit of a complex modeling conundrum, but this is how we represent those. So what we will do is since we saw before impervious surface information for these three parcels, we can sum the square footage for that impervious surface up to this single premise number, if that makes sense. Okay, so we, after having gone through, like I said, what was the largest part of the project from a fee perspective, getting that data synced up, conflating those disparate data sets, and then finally working through kind of by brute force to create that SAP GIS Connect table. How do we maintain that over time? Because we don't just want a snapshot in time. We want to develop a process by which the city can maintain this. So we created some data maintenance tools. It's a Python toolbox with 3 component tools, and this supports what I will call a semi-automated monthly process for data update. I'll just stop there, and there's several reasons why it is a semi-automated process and not a completely automated process for right now. One is that the SAP system itself is undergoing a major upgrade right now, and so there's a lot of moving parts. So we decided to sort of sidestep that by creating inputs and outputs that we are not directly linked to SAP, although that could be a direction we go in the future. But for right now, we take outputs out of SAP, reports that are automatically generated. And then what we produce at the end of this process is something that can be ingested back into SAP. So trying to stay out of the way of that upgrade process that's going on right now. And it's going to take probably several years. So you probably can't read this, and I wouldn't expect you to be able to, but just an idea of how we kind of modeled the tool Essentially moving from left to right, we have, inputs on the left that are various things coming out of SAP. And we've got, parcel data that we get on a monthly basis from Luca County. So we maintain a current set of parcel features, and then we have an updated set of parcel features. At the end of this process, we basically have new information related to parcels and ERUs per parcel, so new impervious surface per parcel feature, and a new and updated SAP GIS Connect table, right? That's taking account of new parcels that have been created or parcels that have been removed, also new premise numbers and new accounts that are coming in SAP. We also have an updated SAP ERU table that's going to provide new ERU values. So let me get into that a little bit, and I'll show you some of the nuts and bolts of that. So the first step in that process is a parcel comparison tool. So this is looking at data from last month, comparing it to data from this month. And again, there's some opportunities to automate this a little better using services from the county. We're not quite there yet. So really it's just a data download and then pumping it into this tool. So essentially what it's going to do is it's going to compare, look at parcels month to month. It's going to look at new parcels. So parcels that were not in the old data set that are in the new data set, parcels that are missing. So parcels that were in the old data set but are not in the new data set. It's going to look at where there's owner changes. It's going to look at where there are size changes. So the parcel number is the same, but the area of the parcel has either gotten smaller or bigger. We're going to call those splits and merges. It's a little bit of license there. We're basically looking at things that have increased by a certain percentage that we can adjust. And we want to just see where those changes have taken place. So you may or may not be able to see this really well, but this is the parcel compare summary table that is output along with a lot of other feature classes. But this is kind of the crux. And really what it's telling us here, just as an example, is we have a parcel number here, and it's indicating here that it has a yes value in the new parcel column, that this is a new parcel. So this is a brand new parcel from last time. So this is either a parcel that was added by the county. And again, this table is really just created to kind of feed into the next step in the process, but a lot of this information can be very beneficial, not just for this process, but actually outside of the stormwater process as well, looking at those parcel changes from month to month. So this gets a little more integral to the process. This is really providing data updates to the SAP data. So we take as inputs in this tool, we actually take that parcel compare summary table that we just created, and we feed that into here, and then we take the current data that has come out of SAP. So again, like I said, we're working with that team that's doing that SAP upgrade to get what we need out of SAP for the time being. Ultimately, we're going to automate that process so that SAP will output that data again on a monthly basis to a location on the city network where we can access it. So we're going to step by step keep automating more and more of this process. But one of the cool parts about this tool is it's going to look at new premises. So now we're comparing SAP data in the same way we compared parcel data. It's going to look back at SAP data. It's going to say, oh, we have new premise. We have new premise information. It's going to link that premise to the account. It's going to have an address associated with that account. And it's going to geocode that address. And where it can, it's going to plunk it inside of a parcel, and it's going to make a new connection in the SAP GIS Connect table. So all that process is automated. Of course, that doesn't always work. And where it doesn't work, we flag that. And we provide that information to the GIS team for their review and manual process if necessary. So just an example of this record here, we have a new parcel geocode. It gives the date. It also indicates that the owner changed for this particular parcel, which could be a reason why that there's a maybe there's a new premise number that could be related. But the important part to take away here is that we have a new connection that was done automatically by the tool. And then finally, we have an impervious update. So as you can imagine, with parcel data changing month to month, we're going to have new impervious values. So to maintain that over time, we're going to create a new per parcel impervious data layer. So that's what this third tool does. And the tools can be run individually, but they are meant to be sort of run in succession. You can actually, they kind of build off of each other. So you don't have to run tools 2 and 3 after running tool 1. You can run tool 1 just for if you have a specific need. But this does a couple things. This creates that new impervious data layer per parcel. It also creates an update, and I'll show you right here, an update of that table that came out of SAP that contains the ERU values on a parcel by parcel basis. So, I'm sorry, on a premise by premise basis. So this is going to give you what a new calculated ERU is, what the ERU delta is. And I will say there is some rounding that takes place with the ERU values. They're usually just in whole numbers, so they're rounded up or down depending. So an ERU delta of this nature right here, we would just ignore. For residential parcels, of course, we're not really concerned about that in any case because we're just charging them 1 ERU. But again, this is information that can be then fed back into SAP. It's not done in an automated fashion right now, like I mentioned. Part of this project too, we did stormwater billing analysis. So we kind of looked at it as is, like with all things being equal. Is the city charging the appropriate amount for their ERU, per ERU? We did comparables to other cities of the same size. And then once we have that kind of all things being equal, when we combine that with the new data, now we have options, right? So we come up with currently the city is charging $3.80 per ERU. The recommendation was that they charge a little more than $2 more than that, like $5.88 per ERU. But if we tweak the way that we're billing some of these things, we can maybe move that number down potentially. For example, we could start charging residential parcels based on square footage instead of ERU. We could create 2 residential classifications. As you can imagine, there's huge residential parcels. There's very small residential parcels, and they probably have a lot different amount of impervious surface. We can include the gravel and the hard surfaces, so the hard packed surfaces, which we haven't done to this point. And then we can, increase the charge for commercial properties based on the new data. And that is in many times the case that we're again leaving money on the table. So once we have the data in place, we are creating internal applications for customer support. So this is just an example of an internal web mapping application that customer support or customer service people on the SAP billing side can use to access information quickly. So they can search by address, they can search by premise number, they can search by parcel number, and they can get to that parcel quickly. They can see the entirety of that premise, so the one to many parcels that actually comprise that premise, and they can provide information to customers, both internal and external. And then public outreach is a big part of it as well. This is just a screen capture from a story map that we're creating that allows ratepayers to come in and actually search for their parcel, get information about the impervious surface that's been calculated. And then there's a lot of other pages here on this describing the process and how the entire program works. So the so what slide, the results, and some of these results have been realized, some of them are still upcoming, but again, the takeaways really are we have a new impervious layer built on repeatable and defensible methodology. So that's the key. There's consistency and it's very systematic. We have updated impervious data per parcel that's being updated on a monthly basis that will lead to the ability to make better decisions regarding stormwater fees. We performed the one-time true-up with SAP and GIS, and then created some tools to support that over time. The rate analysis, factoring all the information in, including the new data, provides multiple options, for increasing revenue. And then finally, those internal and external maps and apps, StoryMaps, particularly for improved, customer service and outreach. So the upshot of all this has been a reduction in staff time for the GIS staff, working month to month to put this together, more consistency and more defensible methodology, and then better customer service. So thank you very much. That's my presentation. I think I've got just a few minutes for questions, if anybody has any questions.
Absolutely. Well, Frank, it looks like we have a question here from Wes Kent in the chat. How accurate is the automated feature extraction portion of the workflow? For example, does it get to say 60% of the way there, and then the manual review and field verification accounts for the rest?
Yeah, I would say it's probably a little higher than that, in that the buildings are probably the predominant impervious surface, and those can be not easily but more easily delineated, just because they do sort of have those hard edges, and we do capture a lot of, based on the LiDAR, some of the reflectivity. And then based obviously on the 4-band imagery, we're able to get, I would say, a high percentage of driveways, sidewalks, etc., on the first pass. And really, when we go in, it's probably closer to like 75%. When we go in to clean up that data, it's really connecting some of those polygonal areas that are obscured by trees, maybe obscured by buildings because of lean, because it's off nadir, that kind of. So again, we have in the past called it machine learning, even used the term AI. I wouldn't go so far, as to say that, but it is a machine assisted process that gets us pretty far down the road without a lot of actual, staff time staring at a screen.
It looks like here and Wes says thank you. Christopher Salient says, is this the model you would run for MS4 program that the EPA is permitting?
It's interesting. I think MS4, there's different data gathering requirements. Certainly the information that we glean here would, I think, go into, that obviously that impervious surface information is going to go into a model for hydrologic modeling purposes. But I know that the city is discussing using that, and we're talking to some other counties around the state as well about supporting their MS4 programs. But yeah, I think there's I know that some of the data collects around MS4, we're adopting a similar process to collect as much data that we can from imagery and LiDAR